Today we're breaking down core network components for the CCNA exam, focusing on how Cisco tests your understanding of routers, switches, firewalls, and access points. The exam doesn't just want definitions. It demands you know where each device operates in the OSI model and its specific role in handling data. A classic exam scenario involves traffic flow. Imagine a user on a PC needs to access a web server. First, the data hits a Layer 2 switch. The switch's primary job is to forward Ethernet frames to devices on the same local network or VLAN. It does this by learning the MAC address of every connected device and storing it in a MAC address table. A common trap on the CCNA is confusing a switch's function with a hub's. A hub is a Layer 1 device that stupidly repeats traffic out of all ports, creating a single collision domain. A modern switch is intelligent. Each port is its own collision domain, drastically reducing traffic congestion. Now, what if that web server is on a different network or subnet? The Layer 2 switch can't send the data there directly. It forwards the frame to its default gateway, which is an interface on a router. This is the critical handoff from Layer 2 to Layer 3. The router operates at the network layer, making its forwarding decisions based on the destination IP address in the packet. It checks its routing table to find the best path to the destination network. A key concept tested is that routers, by default, do not forward broadcast traffic. Each interface on a router is a separate broadcast domain, which is how we segment large networks to improve performance. The exam will hit you with questions that require you to know a router is needed for any communication between different IP subnets. Next in the path, usually at the edge of the network, is the firewall. While a router can perform base packet filtering with access control lists, a dedicated firewall provides stateful inspection. This is a huge distinction for the exam. Stateful firewalls track the state of active connections and can determine if returning traffic is part of an established, legitimate session. They operate at layers 3 and 4, and next-generation firewalls can even inspect traffic at the application layer. Finally, let's talk about wireless access points, or APs. A common exam mistake is thinking of an AP as a router. An AP is fundamentally a Layer 2 device that acts as a bridge, translating 802.11 wireless frames into 802 Ethernet frames to connect wireless clients to the wired network. Management of these APs often falls to a wireless LAN controller, or WLC, another key component in a Cisco environment. To keep these roles straight, remember this phrase: routers route between networks, switches switch within a network. This simple mental shortcut helps you place the primary function of the two most fundamental devices. Routers use IP addresses for inter-network communication, while switches use MAC addresses for intra-network communication. Understanding this division is the foundation for a massive portion of the CCNA curriculum. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.